And then we're going to talk about electrical power. Electrical power, the equation for it is P equals VI. And this makes sense. The more voltage I have, the more power I'm going to be using. And the bigger the current is, the more power I'm going to be using. If I combine that with V equals IR, I can get this set of equations. P equals VI equals I squared R equals V squared divided by R. Now, this is what is on the reference table, but sometimes one of these other forms is going to be a little quicker, so it might help to memorize it. You can always do the problem in two steps, okay? If it gives you V and R and wants P, I could use V equals IR to get the I, then the P equals VI, but it might be quicker just to do P as V squared over R. So here's an example. What is the resistance of a light bulb rated at 40 watts at 100 volts? Remember, power is in watts. Make a note of that. Okay, we learned that back in our mechanics unit. So I was given the power, and I'm given the voltage, and I'm looking for resistance. So I'm going to use this form of it, P equals V squared over R. That's going to be the easiest way. Now, if I'm looking for resistance, I can rearrange this. So I would cross multiply and then divide. I would get R is V squared over P. So it's going to be 110 squared divided by 40. And that'll give us a value of 302.5 ohms. Now, what happens to the power if the electrical potential difference is doubled at a constant resistance? So we have V doubling. We want to know what happens to power. Now, the problem is I have a couple different things. I can do P equals VI. I can do P equals V squared over R. That's why they have to tell me this constant resistance part. Because that's going to tell me I want to use the one with resistance. So it's going to be P equals V squared over R. Now, so if V doubles, what's going to happen? This is telling me P is proportional to V squared. So I put it in 2 because the V is doubling and square it. And I get that the power will be 4 times as large as it was before. Next one, a current of 4 milliamps flows through a 20 ohm resistor. How much power is used by the resistor? So I have I is 4 milliamps. Milli is times 10 to the minus third. The resistance is 20 ohms. And I want to find power. So if I look up above here, the one that has I and R in it is P equals I squared R. So that's going to be 4 times 10 minus third squared times R. 20 equals 0.00032 watts.